Here we go. Let's bring him in. Judd,
Hey,
there you
good
go.
morning.
You obviously did a little troubleshooting and you got in.
Yes, sir, I did. How's everybody doing this morning?
Yeah, good. We just had a connection from the ship. They're making their way to Rapa Nui. They should be there about the 3rd is when they're expecting to come in, and they're just preparing right now. They got some crazy winds coming, so the captain's really excited to harness those winds, and he thinks they might get there a little bit early, so that's kind of cool.
Oh, wow. Outstanding.
Yeah. Well, Judd, it's so good to have you here with us. I know it's early for you in Phoenix, but I did want to see if we could get you, because hopefully over the next few weeks, we're going to do some cool live stuff with you as you're doing some really great science in the field. And that's what we're going to talk about today. So first of all, let's get you to introduce yourself, Judd, and tell us a little bit about what you do.
All right, my name is Jut Wynn. I am a research professor at Northern Arizona University in Flagstaff, Arizona. We're at 7,000 feet in the mountains of the Southwest. And in terms of what I do, I am an ecologist, a conservation ecologist, and focusing principally on cave ecosystems. And how I got involved with Darwin 200 is because back in when my work on Rapa Nui started in, my goodness, first trip was in 2008. I have been there 5 times since. This will mark my 6th trip to the island. And what we found on our first 2 expeditions was we started turning up these insects, which turned out to be endemic to the island, meaning that they occurred on Rapa Nui and nowhere else in the world. And then we also turned up a couple of insects, which were also known as Polynesian endemics, meaning that they occurred in Polynesia and nowhere else in the world. And this was interesting because a few of these Polynesian endemics were actually we believe, and this is clearly right now a hypothesis, which we are going to be testing on this expedition, is we believe that they were dispersed by the ancient Polynesians. Because when the Polynesians were in their double-hulled voyaging canoes, traversing the South Pacific, traveling eastward from points further west, islands further west, all the way to Rapa Nui, they would carry with them plants in gourds, and they were called canoe plants. And these folks were very smart. What they were doing was they had realized that, well, much like when we do a car camping trip, we want to take all of the creature comforts with us. Well, for the ancient Polynesians, those creature comforts were food. And it was food that they could use for medicinal purposes, for making nets, for making rope, and for food, of course. And they would take these gourds and they would have this, cultivars, small plants within them, saplings, and then they would introduce them as they would move across Polynesia. And through this process, these plants were introduced. And at the time, it's not like there was a Department of Agriculture that would inspect what they were introducing. And when they were doing that, they would also be introducing the insects that were within the soil. And we believe that there are at least 3 species thus far that have been introduced in this manner. So we're going to be looking for those animals, as well as potentially other Polynesian endemics that might be canoe bugs. And also we're wanting to potentially debunk this hypothesis as well. So we're looking for other alternative explanations. We hope to be sampling the open ocean, to be looking for floating or rafting terrestrial insects. And we're also going to be keeping an eye out for rafting debris, like big branches or coconut palm trunks, that sort of thing, so we can see if there are any arthropods floating on on that debris.
All right. Very cool, Jet. I'm very excited about this science because it's good science. We've got a great hypothesis to test where there's some evidence for a theory one way, but the thing about science is sometimes the hypothesis is wrong, and that's a valid part of science too. That's why we go out, we ask these questions, and then we usually come back with a whole bunch more questions. So I'm sure you're getting pretty excited to get out there.
Oh, indeed, indeed. This is an opportunity of a lifetime for me to actually test this hypothesis. I've as science typically works, we take maybe a step forward and a couple of steps back, and it just moves. Science does move very slowly for the most part. Sometimes we do have these big leaps and bounds in terms of making progress and discoveries, but what we're seeing here is an opportunity to actually test this idea. And like I said, at the same time, to look for alternate explanations as well, because we don't want to become. I'm not. It's an interesting idea. It's certainly compelling and exciting because we're tying, ancient culture to how animals may have dispersed. But at the same time, we got to be wary and say, well, there are other possibilities,
Yeah.
and we got to equally ferret those out as well.
Absolutely. So classrooms tuning in, if you do have any questions for Jut as we're having our conversation, please put them into the chat sidebar. I'll keep an eye out for those. But I want to ask you, because we talked about Rapa Nui, but you have explored caves in places all over the world. Can you tell us about some of the other places you've been?
Oh, shoot. Yes. So I have worked most recently, been working in Belize. I've been down there past few years. Golly, let's see. We're working on 4 or 5 research trips down there now. And one of the things that we're doing is we're looking at novel animal behaviors in caves, specifically by using trail cameras to monitor animal behavior. So we're putting these trail cameras in these caves and letting them run for an extended period of time. And in this case, we have in 2 areas, we have cameras have been running for at least 1 year. And in another area, we are looking at almost 2 years of collecting data. And we have some really interesting results. We're getting a lot of jaguars. We have the first evidence of jaguars actually using caves as a feeding site. We also have a bare-throated tiger heron that was actually hunting or fishing, as the case may be, underground. So we're really making some contributions in that regard. That's been really exciting work. We're also working on, we're studying bats down there. I spent last summer getting bit about every night. It's interesting because I've worked in the Southwest for so long with bats, and comparatively speaking, bats up here are very docile compared to bats down in Belize. They're all teeth, and they're just like, when you have them in your hand, and they're just constantly trying to bite you. So as a result, I got bit quite a few times. So in Belize, I've done a lot of work, as I mentioned, China, Spain, where else? Hawaii, throughout the American Southwest. I think that's it. Maybe not. But yeah, for right now, that's it's pretty early in the morning, and I haven't had a lot of coffee in me, so I'm kind of waking up.
No worries. That's a pretty good list, Jut. But your explorations of caves aren't just on our planet. Can you tell us about a little bit of the work you've done with NASA?
Oh yeah. So in way a long time ago, we led a project 2008 to 2011. We did a study to characterize thermal behavior of caves, and we did that by collecting temperature data using these HoboPro data loggers, and we deployed them in caves in the Atacama Desert in northern Chile. Hey, I also worked in Chile, and the Mojave Desert of Southern California, and the project culminated by us going in or flying a NASA aircraft rather over the Mojave Desert, and we collected thermal imaging. And we use this thermal imaging because thermal imagery, what you can see is if you were looking at me right now in a thermal image, I would glow like red and orange colors, and everything behind me would be probably these bluish colors because it would be cooler. The background would be cooler and I would be warmer. Um, and so that's what the same principle holds for caves. The entrance was either cooler or warmer than the surrounding terrain, and we actually did a paper on that a while back. And since then, and the reason why that's so important is because we're using these as using those sites as what we call Earth analogs, because we believe them to be analogous or similar to places on other planets that might support caves. And right now we have found cave-like features in 11 different planetary bodies across our solar system. And there are what we call speleogenetic processes, in other words, cave forming processes that have been documented from Mercury all the way to Pluto. And that's super exciting. We've done several papers on that. I've collaborated with NASA folks and European Space Agency folks from all over the world collaborated with us on these studies to inventory caves across the solar system.
All right. Very cool, Jet. We've got a question here for you. Working in the caves, have you ever gotten lost in a cave before?
Oh, ever gotten lost? I would not say lost. I would say I've been turned around on a couple of occasions. We ultimately do find our way out. We do have cave maps, and once you've done this for a while, you do develop, I guess, a fair degree of acuity in terms of knowing your way around, recognizing landmarks as you're moving through a cave, so that you can orient yourself so that if you do get turned around, you can figure your way out. What does happen, being a scientist and basically being a 10-year-old kid in an old guy's body, is that you see things and you get excited when you see things. And you're like, oh, look at that. Oh, look at that. And when that starts happening, you can get turned around. And that's typically when those occasions have occurred. When I get turned around, I get excited. And then all of a sudden I realize, oh, where am I? Oh, okay. And then I have to figure out where I am.
All right. What's the most interesting species you found in a cave?
Interesting species. Ooh, that's a good question. Wow. Well, I guess, are we talking big or are we talking small? If we're talking big, for me, jaguars. We've documented jaguars quite a few times in caves. We found evidence of jaguars on numerous occasions. That the example that I provided earlier about documenting jaguars using caves as a feeding site. We were working in this one cave in Belize, and we're about 300 feet underground. About 100-ish meters, and we're underground, and all of a sudden we see jaguar poop, and we're like, oh wow, okay, jaguar poop, that's interesting. Well, at the time we didn't think it was jaguar poop. We just knew it was really large carnivore, and with jaguars being the largest one down there, we were like, yeah, it's probably jaguar. It could be mountain lion, or what they call puma down there, but it was like, we're probably pretty certain it's jaguar. And then we found a bone scatter. And then we realized at that point that it was a peccary, because we found the skull, big canine holes through the top of the skull. And we were like, wow, this is super neat. And then later, a couple of weeks later, we pulled the trail camera footage. And then we're like, ooh, definitely jaguar. So big animals, jaguars. In the fall, I'm going to be going to Bhutan with a similar objective. But at this point, we're going to be looking for tigers. So big cats are certainly really cool. You don't want to encounter them in a confined space. That would not be good for the researchers potentially. But collecting the footage and finding the evidence, super exciting. Very small animals. I think perhaps one of the neatest ones that I keep leaning on is We found in China, in southern China, what are called dragon millipedes, and those are super neat because they have like these spines along their back, which is how they got their name because they kind of look like dragon spines.
All right, very cool, Jet. All right. So how many days do you have, Jet? When do you take off? I think on the 2nd. Is that right?
I'll leave on the 4th.
Okay.
And it's overnight, very fun flight down to Chile, and then from there I got a very tight layover, and then boom, head out to Rapa Nui from there.
Yeah, we're keeping our fingers crossed. Things go smooth on the tight layover. I'm sure we'll get you there one way or another. But we can't wait because the next time we connect with you, it should be from Rapa Nui, and hopefully we can see you in action in the field.
Yes, that would be wonderful.
Awesome. Well, Jet, thank you so much. I know you've got lots to do to prepare, so thank you for getting up early and hanging out with us. Get a few more cups of coffee into you, and yeah, I'll talk to you soon.
Joe, thank you. And thank you, everyone. Pleasure to be here. Y'all take care.
See ya.